Recitation problem 1. Two soccer players start from rest 48 meters apart. They run directly toward each other, both players accelerating. The first player has an acceleration that has a magnitude which is 0.5 meters per second squared. The magnitude for the second player's acceleration is 0.30 meters per second squared. Now the questions are: A, how much time passes before the players collide? 2, at the instant they collide, how far has the first player run? As usual, we put together a diagram to describe this motion here. There are two players. Let me represent player 1 by a box here. This is player 1, and player 2 is coming from the other side. So player 1 is going this way. Player 2 is coming this way. I need a system coordinate to describe the motion. I'm going to set it up to point towards the right, and the 0 is going to be set up where player 1 is located. That's for simplicity. So this is my 0. This means that player 2 is located at x equal 48 at the moment when the motion began. Since player 1 is accelerating at a larger magnitude, they're going to meet closer to player 2 than player 1, somewhere around here, okay? This is where they're going to meet. I'm going to call that point x. Now we're ready to write down the equation of motion for player 1 and the equation also for player 2. Notice that when they meet, they're both going to share the same position x, and also they're going to travel the exact same amount of time. So the best equation that describes this particular example here is the x versus t relationship, and the equation of motion is the following one: x equal x0 plus v0 t plus 1/2 a t squared. Okay, to differentiate player 1 from player 2, what I'm going to do here, this is x0 for player 1, v0 for player 1, and also the acceleration for player 1. Now for player 2, we're going to have to write the same exact equation. Player 2, x is going to equal x0 plus v0 t plus 1/2 a t squared. In a similar way, I'm going to put here x02, v02, and a2. Time to substitute for the known quantities for both equations. X equals, what's this? Start from 0, right? Plus start from rest, plus 0 also, v0, which is 0 times t, give me 0, plus 1/2. The acceleration for player 1 is 0.50 times the t squared. Alright, the equation for player 2, x equal, the starting point for player 2 is 48, so be careful here. This is 48. Alright, start from rest means v0, 2 times t is going to be 0. The other thing that we really need to be careful with here is the acceleration. Which way player 2 is moving towards the left, means the acceleration vector is pointing towards the left. However, which way is my positive? My positive is towards the right. Therefore, the component of the acceleration for player 2 is negative 0.30. Be careful with this one, right? It's all about components when it comes down to vectors. Now at this point in time, all we need to do is equate the two equations, because at the moment when they meet, they share the same position x. As a result, what do we have here? The left hand side is 1/2 times 0.5, that's 0.25 t squared, equals, what do we have there? 48. We have negative, here's the negative, 0.3 divided by 2, that's 0.15 t squared. Let's move the like terms to one side of the equation. 0.25 t squared, that one we move it over, it becomes positive 0.15 t squared equals 48. This is 0.40 t squared equals 48. Just solve for the t here. You will get t equals 10.95 seconds. To solve for part B, which is at the instant they collide, how far has the first player run? So we need to use the equation for player 1, okay? Player 1 equation, x equals 1/2 times 0.50 t squared. All you need to do is substitute the t here and solve for the x, and the answer is going to be, alright, as I said, this t here should be 10.95 equals 30 meters. And that's it. The first player is going to travel 30 meters. Obviously the other one has to travel only what? 18, because the distance between them is 48.